Hello, my name is Tal Nguyen from Teradata. I'm joined by Lisa Dawson from SAS
Hello.
and Paul Siegel from Teradata.
G'day.
And welcome to the Technology Showcase from SAS and Teradata. Today, we're going to show you the end-to-end capabilities that we can do with SAS and Teradata technologies. First, we're going to show you how to cleanse your data using Data Quality Accelerator. And then we're going to show you the Code Accelerator, how to manipulate and prepare the data for analytics. Then we're going to proceed with SAS formatting, and then apply some of the Analytics Accelerator and Score Accelerator to round out the end-to-end capabilities. So Lisa, I'm going to turn over to you to give the audience an overview of the process.
I'm actually going to start with Access because what Paul has already done is loaded some data using our Access technology, our SAS Access to Teradata engine to get the data started. So little known fact about SAS is that a very large portion of our revenue actually comes from our Access technologies. You can't analyze data if you don't have data. So what's great about SAS Access? Well, for starters, it's native access. And so what do I mean by that? Well, it means that we can leverage native database utilities as well as automatically format data to and from your SAS environments, and we'll see some of that throughout the demo. So as I mentioned, Paul has already done some data, loaded some data using the Access to Teradata engine that under the covers is also utilizing Teradata's fast load utility for loading that data. But what Paul's going to start with is showing us some of the data quality functionality and some of the functions that can be used to cleanse and enrich some customer demographic data. A note on data quality functionality that's important is that included with the product is something we refer to as the Quality Knowledge Base, or QKB, which contains all of the knowledge necessary for parsing, standardizing, matching, and identifying data, which you'll see some of. And it is both location and language specific in what we term locales. So, Paul?
Thank you. So I'll start off by connecting to a Teradata machine in San Diego. It is a 6-node 2800. And I will also turn on some logging and some other options. So the logging will allow us to see what is sent through into the database. So that all ran nicely. So now we'll start looking at the data quality portion. So I'll give you a quick look at the data. So we have 1 million rows, and the raw data looks like this, where we have a customer identifier, the title, full name, street address, city, state, zip code, country, email address, telephone number, birthday, and a credit card type. And one thing to notice, the birthdays are in SAS format, even though they came from Teradata. Now, it's just by a quick visual inspection of this data, we can see that there's some problems with the states. We have some states with the 2-character abbreviations, and we have some that are spelt out. You can see California, New York, New Jersey, and so on. Also, we don't have any gender information. So what we're going to do is to use the Data Quality Accelerator functions to have a go at identifying the customer's gender and to standardize those state codes, so it's all the 2-character abbreviations that everybody expects. So we'll start off by doing the gender identification. So the way the Data Quality Accelerator works is there are some stored procedures that are deployed in the Teradata database that make use of that quality knowledge base. And they also make use of DS2 code, which we'll talk about later on in this video. So I'm going to call this DQ gender, which, if you're familiar with SAS's data quality capabilities, you'll notice is very similar, if not exactly the same, to the way we would call these functions on other platforms. So I'm going to call the DQ gender. I'm going to tell it the data's coming from this cust VW. I'm sending it the full name column, so that's what it will use to try and identify the gender. I'm going to keep the CID, the customer identifier, so I can link it back. The results are going into a new table called cust_gend, And I'm using the English USA quality knowledge base. So it's going to be able to pick up American, English, Anglo names. So let me just run this. And it shouldn't take too long. Should just about be finished. And it took 8.86 seconds to do gender identification on 1 million records. So we can actually have a look at the frequency. So I run a proc freak. And we can see we have 44.04 female, 46.34 males, and we have this 9.63% unknowns. The reason they may be unknown is we may only have a first initial for the person, or they could have a non-Anglo name, like Tar, or they could have one of those gender-neutral names, like Lindsay or Kim or Casey. So if it was important that we get all the genders identified, we could pull out this list of 96,000 customers and send it to somebody, probably a poor intern, to go through and visually inspect and try and identify the gender. Now, the other thing I want to make mention of while I'm on here is this proc freak. You'll notice it's exactly the same code that you've always written for a proc frequency. But if we look at the log, notice the magic blue words here. SQL generation will be used to construct frequency and cross-tab tables. Now, what's happened is the Access engine has looked at this, realized this data is sitting inside Teradata. So what it will do is, instead of pulling back the entire 1 million rows into the SAS server, it will actually just go through and send SQL off to the Teradata server. Teradata will execute that SQL and just bring back the results set. So instead of bringing back 1 million rows, it's going to bring back 3 rows. And SAS will then make it look the way we've always expected it to look. And because I've got logging turned on, we can go up here and we can actually see the SQL that was sent through to the database. Okay, so now we'll go and have a look at the state codes. So again, I'll do a proc freak. And we can see Arizona, California. We actually have 2-letter abbreviations for both of those as well as the full name. New Jersey, New Mexico, New York, and Ohio. Can't forget poor old Ohio. So what we'll do is we'll call the DQ standardize function, and we'll pass in the type of information, the type of standardization we want. And this is just one of many different types of standardizations we can do. So we're going to tell it we want the state province abbreviation. Bringing it from the cust view, passing in the state information, bringing back the customer identifier, and putting it into this table at the end.
So one of the things that I mentioned before with the quality knowledge base, it was containing all of that parsing, standardization, matching type logic. This is an example of utilizing the state province abbreviation definition that comes out of the box. So there's quite a bit that you get from a out-of-the-box perspective to help clean up your data.
And 5.28 seconds to go through and cleanse that those 1 million records. So now we can go and look at the output table and make sure everything is behaving. And we can see we've got just the 2 character abbreviations the way we expect it to look.
Okay, so now what we're going to walk through is some examples utilizing Code Accelerator. So data that's used for analytic purpose is rarely ever structured or prepared the way it needs to be for the analysis that you want to do. Data preparation is always required. So we're going to walk through some of that process using Code Accelerator capabilities and some SQL capabilities. You'll hear us refer to something called DS2, which is a language that's been developed in order to work within database environments. And keep in mind, it's fairly easy to take any existing dataset programs that you may have that prepare data and convert them into this DS2 language in order to run inside of Teradata. So Paul?
Okay, thank you. So we've now done some basic data cleansing on the demographic data. Now we'll start looking at the transactional or behavioural data. So we've got some raw data that looks like this. We have a customer identifier, a customer number. We have some dates. We have some transaction counts. And we have a total of 365 million rows. Not large, but not small. Just a nice size. So first thing I'm going to do is take that date field that was in there and strip out the month and put that into a separate table. There's only 1 year's worth of data, so I don't need to worry too much about the years. So I'm going to do this using proc SQL. Now this is what we call implicit SQL. So this is SAS's dialect of SQL. And I'm using a SAS specific function called month, which goes through and pulls the month out of a date column. If you know Teradata SQL, you'll know there is no month function that works like that. So what will happen? So let's run it and see. Well, the simple fact it ran in 7.14 seconds tells us it didn't pull data out over the slow corporate network. And if I scroll up here and look at the SQL that was sent through the database, you'll notice it's rewritten that month function as extract month from, which is ANSI standard SQL, which Teradata understands. And there's there's about 100 functions like that, those SASisms, that will be converted into Teradataisms automatically for you. So our data now looks like this. We have the ID, we have the month number, and the transaction counts. So what I'm going to do now is take that deep, narrow table and basically pivot it or transpose it. I want to roll it up to the customer level, and I want transaction counts across all those transaction channels by month. So the way I'm going to do that is I'm going to write myself some DS2 code. So DS2 is a modernization of the data step code. It adds in some fairly significant features, including things like thread control, so you can actually write multi-threaded programs. It adds in methods, it adds in packages, and it adds in some support for some ANSI data types. So you can in DS2 you can actually deal with big integers and big decimals. So you're no longer limited to a double numeric value with its 16 significant digits. So I'm saying proc DS2, DS2 Excel equals yes, so push this into the database. And what makes this special is it doesn't actually get translated into SQL. It runs natively inside the database, inside the SAS embedded process for Teradata. So in my code, I'm defining some threads, and I'm defining some arrays. So these arrays are going to handle the transaction counts over the month. Defining an average amount, declaring ID as an integer, some keep and retain statements. All fairly standard so far. Then I come down to this method. So I've got a method called clearArray, which just goes through in a do loop and zeroes out my arrays. So it basically resets them. Then I have a method called run, and this basically contains the analytical body or the process body that will be run. So if we're going to run this in a multi-threaded mode, it's this run module that gets fired up in multiple instances for each thread. So I'm doing set tx month, which is coming from Teradata. I'm doing by group processing, so by ID. And then I've got standard style first dot, last dot processing. Now, if you've ever had to try and convert first dot, last dot processing into set-based SQL, you'll know it can be a real pain in the backside to try and do. By having this run inside the database, we can alleviate that pain because it runs natively. So if it's the first occurrence of an ID, we're going to go through and call this clear array method, so we're going to basically reset our array. Then for each element or for each member within that ID, we're going to go through and do the transaction counts and create a T1 average over the entire lot. Then if it's the last of the ID, we'll write the output out. This part down here, this is actually where we can instantiate the multiple threads and fire off that run method. So if I was running this on a SAS server, I could specify how many threads I wanted. So let's say I'm running on a 16 die, 2 core on each die processor, giving me a total of 32 threads. I could specify I want 16 threads running. And it would fire off that 16 instances of that run method. Because I'm on Teradata, it will ignore whatever threading you specify and automatically default to 1 thread per amp. So on my particular Teradata box, I'm going to fire off 240 threads. So I'll get 240 instances of this running simultaneously. So let's just go and give this a run. So it's going through, instantiating all the threads, running it, and should just about be finished. So just under 12 seconds to take that 365 million by 6 columns to 1 million by a lot more columns. In fact, let's actually have a look at what the results look like. So we've gone from that thin data set to something that now looks like this in 11 seconds. Pretty impressive. Now I'm going to calculate some more variables, but this time I'm doing it via proc SQL. But what makes this different is I'm using explicit SQL. So this is where I just get SAS to send the SQL off into Teradata without touching it. So I can use the Teradata extensions to SQL that SAS does not understand. There's nothing special in this particular code. I could have done this in the DS2 as well, but I wanted to show this particular style of coding. So I run this, and it goes through and took less than 1/3 of a second to do this. Now I'm going to create a view that joins all my data sets together. Now what's different about this, and this will only work in SAS 9.4 M3 and above, is that I'm using implicit SQL. There's no connect to Teradata, but I'm actually creating a view inside Teradata. In previous versions, this would actually create a view in SAS Work, which means every time I hit that view, it's going to bring back all the data into SAS Work. This will actually create now a view inside Teradata, which is a nice big savings. So I'm joining my demographic data, my two cleansed tables, so the one with the gender identification, the one with the cleansed state code, and all those transformations I just built. And now my final data set looks like this. And if I was running this from start to finish without stopping and explaining all this stuff to you, it probably would have a runtime of about 20-25 seconds, which is pretty phenomenal.
So, Paul, as you know, SAS formats are hugely popular with SAS users. And just like the base SAS procedures that we looked at and some of the other work that you've done, all of those can be leveraged inside of Teradata as well. Can you show us some of that?
I sure can. So here I have a format defined. Fairly simple. It can be as complex as you want. It can be hierarchical in nature. I've yet to see any formats that can't be pushed into the database. So I'm defining this format. And now what I can do is I can actually publish this format into Teradata. So Teradata is now aware of it. So as soon as it sees any function or any use of this format, it will actually run with it in place instead of sending all the data out to SAS.
And because we're doing that inside of the database with the data itself, does that also mean that non-SAS applications and non-SAS users could leverage the benefit of those formats?
Definitely.
Okay, great.
So I'm going to initialize the macros. And then I'm going to send the macro. I'm going to start another macro that will actually send that format into the database. So I'm telling it where it lives. In my case, it was in SAS Work, the database it's going into. I'm creating a table that will hold all the formats that I have published. So in 2 weeks' time, I can come back and actually remember what I've published. And the way this works is it actually generates C code, puts a wrapper around it, compiles it into what's called a vendor-defined function, and deploys that into the database. So the difference between a vendor-defined function and a user-defined function is this is supported. And if something goes wrong, you can hop on the phone, complain, and it'll be fixed. And it doesn't matter who you complain to. You can complain to Teradata or to SAS. We'll sort it out between us whose problem it actually is, and whoever you contacted will get back to you with the fix. So now I'm going to run a proc freak and apply that format, that txncat. Click the run button. And you can see the format has been applied. The fact it ran quickly is a good indication it ran in database. There's the magic blue words that will come out even if you don't have the logging turned on. And if we look at the SQL that was sent through, it actually rewrote the SQL to apply the format. So there's case statements in there to apply that format. The reason it did that is native SQL execution is quicker and faster and less resource intensive than calling a vendor-defined function. If for some reason it can't rewrite the SQL, or if you want to call the SAS format from another third-party tool, you'll see a call to a SAS _put function. That will actually make use of the format by the VDF.
Okay, so we've seen up to this point some base procedures again being pushed down. We've seen some data cleansing functions utilized inside of Teradata. But what the analytics accelerator that Paul's going to show you next does is it further extends that SAS functionality that can be processed inside of the Teradata environment, exposing more than just some of these base procedures, but actually exposing some of our analytic procedures. And I believe what we're going to see is proc reg.
Correct. So I've got my data set ready for analytics. I'm going to start off with a linear regression. So I'm doing linear regression and I'm using max-R as my selection criteria. So what will happen is because this is actually inside the Teradata database, the Access Engine knows it can go off and call some functions in the database that will calculate the X prime X inverse matrix in the database. And if I had multiple models stacked up here, so let's say I wanted to do forwards, backwards, and max-R and make sure they all align and it all converges at the same spot, it will actually use that matrix and cache it and reuse it for each model type. Here I'm also putting in saving my regression estimators into work because I'm going to use them for scoring. So let's run this. And this does take a little bit of time to run, but it is running, doing most of the heavy lifting inside the database.
And what's unique about Analytics Accelerator is that this is SAS developed just for Teradata.
Mm-hmm.
So here's my model results. Don't pay too much attention to it. It's artificial data and the model's not much good. So again, there's the magic blue words. SQL will be used for in-database computation of the data set. Now what I can do is I can actually score that linear model inside the database using proc score. So I'm going to score this data set. It's going into this the results are going into this table, ADSP1 underscore linest, and it's going to pick up the parameters that I saved in work in the step above. So let's run this, and I'm scoring 1 million observations, and it's done. Didn't even have time to say it, and it was done. So 1.85 seconds. And just to show you that I'm not pulling your leg, here's the results. And right at the end over here are my results from my estimator, my predictions.
So we saw some score there, but now we're going to talk about scoring accelerator and what that is. So one of the biggest challenges that a lot of customers have is the actual deployment of models that they create within something like Enterprise Miner, because you have to convert the code potentially depending on where you want those things to be run. But with a combination of scoring accelerator and Enterprise Miner and Model Manager, SAS has simplified the process of being able to create, convert, publish, and execute a score inside of the Teradata environment. So we're going to take a look at some of that.
Correct. So I actually have a Enterprise Miner model, which I'm not going to show here. If you're interested in the model, have a look at the individual scoring accelerator video. But it was very simple. It was read some data in, do clustering with 5 clusters. There was a score node and a score export node, and that's it. Now there's 2 ways we can use the scoring accelerator. There's an easy way and a not as easy way. The easy way is to use SAS Model Manager. That allows you to publish straight from the metadata repository. Click a button, it's published in the database. Click another button, it's scored. Also handles monitoring and all that cool stuff for you around the model lifecycle. If you don't have Model Manager, you can still publish this stuff into the database, but it's a bit more of a manual process, which is the way I'm going to show you here. So I'm going to initialize the scoring accelerator publishing module with a macro call. Now there's 2 ways we can actually publish the models. There's the deprecated method, which was our original method, which created several vendor-defined functions actually for each model type. There were some issues around the maintenance of those multiple models, so we replaced it with a DS2 based embedded process style model, which is the preferred method and the way I'm going to show you here. So the way we do that is we take the DS2 code that was generated by Enterprise Miner, and we store that in a table inside Teradata. Now this gives you a bit of flexibility. You could have one table that contains all your models. You could have one table per project, one table per department, one table per product, whatever you feel like. It gives you really good flexibility. In my case, I'm going to create a table in name data called test models, because I couldn't think of a better name at the time. Now into my test models, I'm going to publish that DS2 code. So the score export node in Enterprise Miner allows you to save out some information to the file system. And this is the location on the file system. Then you give the model a name. I'm calling it clustering because, again, I couldn't think of a better name. So I have clustering going into my test models table. If it already exists, replace, and the default mechanism is the embedded process. So I do that, and it's published. I'm ready to score. Now, before I get to the scoring, I just want to deviate a little bit, because the data I'm going to score this against doesn't live on Teradata. It lives in my Hadoop server. So I need some way to get to my data in the Hadoop server. So Teradata has this cool product called Query Grid, which allows you to, from within Teradata, to reach into other platforms like Hadoop and surface the data up, do something with it, and then get rid of it. And if you have any where clauses, those where clauses get pushed down to the foreign machine. So you only get the data you require coming back. We have the DBA create a foreign server. So this foreign server basically abstracts all the technical information away from the user. So the user doesn't need to know what port they're connecting to, what the IP or machine name is, how they're getting data in and out. All they need to know is the name of the foreign server, in this case Apex. So now I'm creating a view which is pulling data from the SAS E2EH schema in my Hadoop server. The data file is actually called cl_prep_out, and it's at my Apex server, which is my Hadoop server. So I can create that view. And now I can actually score using that. So I call a stored procedure, or if I'm using Model Manager, I click the Score Now button. The model table name is my test models. I'm going to score my clustering model, which is in my test names. My data is coming from cluster_hy, which was my view that reaches off into Hadoop. My results are going into clustered out, and I'm picking up my primary key. So let's run that. It should nearly be finished. So 25 seconds to bring my data from Hadoop into Teradata, score and get rid and flush it. Here's my raw data. And if I do a proc freak on that, we can actually look at the cluster information. And we can see it's probably cluster 4, which is the smallest cluster that contains the most valuable information.
Paul, thank you. As you can see, we have demonstrated the end-to-end capabilities of SAS and Teradata to help you improve performance, economics, and governance. By leveraging the Access to Teradata engine, the Data Quality Accelerator, the Code Accelerator, the Analytics Accelerator, and Scoring Accelerator, all of which are well integrated with SAS and Teradata. Thank you for your attention. Lisa, Paul, thank you for your assistance. Have a nice day.